This lecture will be on scopes and closures. You can get a copy of the demo files on the course webpage. Once you have the files extracted, open up VS Code. We're going to go to Explorer, go to the tab No Folder Opened, and we're going to click Open Folder and navigate to the folder that we want to work with. So inside this folder, we're going to click Select Folder. Inside of VS Code, you can work with files or you can work with directories. I recommend working with directories because it creates a workspace where it's aware of all the associate files as well. So let's go to the first file, which is going to be closure.js. Okay. And so inside this file, we have two functions. We have a function print, which just uses console.log to print some input. And then we have a second function, print money, which formats the input as a currency string and then prints it out. So over here, we are saving those two functions. Inside of JavaScript, functions are first class, which means that you can treat them as any other variable. You can store them, you can retrieve them, you can, inside of over here, we are creating object myConsole. Okay, so two curly braces is signaling that this is an object, and we are assigning inside of it, we're initializing it with this object is going to contain the function print and print money. So we can just assign functions as if they were variables. And then inside of here, if we want to use these functions, we can use the dot operator to reference each of these functions. So whether that be myConsole.print or myConsole.printMoney, we can execute those two functions. So to run this, we can go to the Run tab and click Run without debugging. It's going to prompt us to choose an environment, and we're going to choose Node.js, which is then going to run and output the results. Okay, so I'm going to clear this. And before we go to the next example, choosing this environment every time is a bit annoying, so we can remember that we always want to choose this environment. To do that, we go to the Run tab. And over here, we have over here it says to customize and debug, create a launch.json file. So we're going to click on this link in the middle. And it's going to ask us again to choose which environments. We're going to choose node.js. And we need to make one additional change. So right now, this program property is going to always execute the file closure.js, which typically is very common because you typically, when you're writing a program, you might have hundreds of different JS files, but you only have sort of one main.js. This is not the case for us because we're running several, we're running like 10 or 15 demos, and each of them is going to be a different file. So instead of having this over here, we're going to change it to $file. And this is going to automatically run the file that's currently open. Okay, so I'm going to save. And then I'm going to close. And then from here, from inside closure.js, if I run again and I click Run without debugging, it's not going to prompt me this time to choose environment. Okay, so I can clear this. And let's move on to the second demo by going back to the Explorer and Closure 02. In the second demo, we also have a print function. We have an object myConsole, this time with only a single property print, which again references the print function. And we have a second object, otherConsole, which is initially empty. This is just the empty object, empty set of braces. And on the next line, we create a new property called print. So we say otherConsole.print. This doesn't exist, so it creates it. And it's going to be assign the value myConsole.print. So this is just showing that we can treat functions as any other variable. But if we're doing so, we don't include parentheses. If we include parentheses, this becomes a function call. Okay, so once we have this assigned, we can call that function using other console.print, and then we include braces to make the function call to run it. Okay, so let's run this. Okay, and you can see that this outputs 10 million. Okay, but again, notice that because we set up the launch.json file, which we can see underneath inside of this VS Code folder, because we set this up, it knows the environment, it knows that it's always going to use node.js, which speeds up our debugging. So the third example is just a more concise way to do the second one. So instead of having a object initially empty, over here we define a object other console, and it has a print property which has the value myConsole.print, which refers to this object's print function. Okay, and we can actually rename this function. So we can call it, let's say, myPrint. And in this way, we can rename functions if we don't like the previous name. So let's run this. Okay, and again, we get the number 10 million. Okay, let's move on to the fourth example. So inside of JavaScript, we have three categories of scope. We have global scope, which we should really avoid. We have function scope, which we'll look at next. And then we'll have lexical scope, or also called block scope, which we'll look at last. So global scope, you usually want to avoid. Variables that are defined without any keyword, like var or let, are defined to be global. And the problem with global scope is that you can use those variables anywhere, and they all refer to the same variable as long as they have the same name. So over here, let's look at the functions that we have. We have a function foo, which changes a variable myvar to be 5, and then it prints it out. So the second function over here, bar, prints out the variable myvar. It declares a function baz, and baz just changes the value of myvar to 15, and then it returns that function. Another feature of first-class functions inside of JavaScript is the ability to return functions as output. So when foo executes, the variable myvar is declared to be global, and it's initially assigned the value 5, and we print it out. So we print out a 5. Console.log myvar, because this variable was declared to be global, we can use it anywhere, including over here. It'll take out, again, the number 5. Over here, we change the variable myvar to 10, and then we call bar. Okay, so bar, in this case, prints out myvar, which has been changed to 10. So we print out 10. Then it declares this function and returns back the function baz. And that gets assigned to the variable mybaz. We can then call mybaz, which changes the value of myvar to 15. And finally, if we print out myvar one last time, it becomes 15. This becomes much worse when we start working with asynchronous programming, and a variable can be changed silently a few seconds after some delayed callback executes. Definitely try your best to avoid using globals. Next, let's run this just to confirm. Okay, so over here we see 5, 5, 10, 15. So function scope is the next category of scoping. Variables defined as function scope can be accessed anywhere from within the function that they are defined, including nested functions. In order to declare a variable to be function scoped, we use the keyword var. In this example, we have a function parent, which declares the function scoped variable x to have the value 1. It declares a function foo, which prints out x plus 1. Notice that because we have this nesting, foo should be able to access the parent scope. Afterwards, we call foo from within parent. If we call parent here, parent will call foo, and foo will print out x plus 1. So this should print out 2. But this line, console.log x, should not work. Because x is defined to be function scoped, it is only accessible from within parent, including any descendant functions that are nested inside of it. So if we run this, we will see that 2 prints out, but then we get an error, x is not defined, when we reach line 10. In this example, we have a function parents, which declares a function scope variable x and assigns it the value 1. Then declares a function foo, which inside of it declares a function scope variable y and assigns it the value 1. It then declares a function bar, which prints out the value of x. And we can see that this is fine because the variable x is scoped to the parent. Where we get into trouble is on the next line, where we try to access the variable y, which is scoped to foo. And we cannot access y because it's not inside of the scope of bar, nor its parents. So when we run this, 1 will print out for x, but for y we'll get an error. Okay, so it prints out x and 1, and then before it gets a chance to print out y, it says y is not defined. In this next example, we'll look at the drawbacks to function scope. We have a function foo over here, which loops from 1 to 100, and then it prints out the variable I. And we'll see over here that the variable I is still accessible. It will print out the value 100. Okay, even though that the variable I was declared inside this loop. Function scope is, as its name suggests, scoping to functions. It does not scope inside of loops or conditional statements. Next, we have 2 conditional statements, one that always runs and declares a variable x to be 5, and one that never runs and declares a variable y to be 7. And we'll see that when we run this, the first line is expected. This will always run, so it prints out 5. But this does not throw an error. It just is undefined, which is strange because this line should never execute. So let's run this. And you can see that I has the value 100 even after we're outside of this loop. X has the value 5. And y has the value undefined. Okay, so on the next example, we sort of look under the hood to see what JavaScript does to cause this with function scope. When variables are declared to be function scoped, you can think of it as having their declarations, not their initializations, but their declarations move to the very top of the function. Okay, so on top of here we have var I, x, and y, which are our 3 declaration statements from previous, move to the very top of the function. And then all of this suddenly makes a lot more sense. Because I was declared on top of foo, of course we should be able to access it from outside of here. And the same with x and y. Okay, so x, again, this is always going to run. But for y was never supposed to run, but because we hoisted the declaration to the top, it gets all 3 of these values are initialized with undefined, which just means that it's not been set yet. And then over here, I gets set to be some value 0, and then loops through until it gets to 100. X becomes 5. And then y, because this never fires, it never changes to 7. It stays as undefined. Okay, and that's why this is what JavaScript does under the hood. Okay, so again, we see the numbers 100, 5, and undefined. Next, we'll look at lexical scope. So lexical scope scopes to the block, which we can think of as the set of curly braces, which includes for loops, conditional statements, switches, and functions, of course. And variables are defined to be lexical scope using the let or const keyword, where let is a variable that can change and const is not allowed to change. Okay. So lexical scope is very similar to function scopes, except that we can also use it from within for loops and if statements. They can access the parent scope variables. So if we change our code to, instead of using var, to use let, then this entire block is going to change significantly. So I've commented most of it out because now we're going to get a lot more errors, which is actually a good thing. Typically, as you get more proficient with coding, errors become very helpful to notice what is working and what's not. The sort of worst thing to have is a silent error that doesn't jump out at you and point to the line number that's causing the problems. So I'm going to uncomment this first line out. And so after this loop, before we printed out the number 100, and if I save and I run this, we can see now it tells us that I is not defined, okay? Because I is not defined inside of here. So I'm going to uncomment that, and let's move on to the next one, X. And we will run this. And again, because X is defined inside of this if statement, as soon as we exit this if statement, it's no longer accessible. And so this is also going to print out reference error. And of course, because this is the exact same issue with Y, this will also yell at us that Y is not defined. Okay, so that's the key difference between function scope and block or lexical scope. Lexical scope defines the behavior of nested functions. This example, print, is nested inside of foo. And when this occurs, the inner function has a link to all variables available in its parent scope. So in this case, the print statement is able to access B. So when we call foo of 1, B gets assigned the value of 1 plus 1, which is 2. And then we define a function print. And then we call print of 2 plus 1. So that's going to be our C value. That's going to be 3. So when we do console.log, it has access to A, which is 1. Has access to B, which is 1 plus 1, which is 2. And it also has access to C, which has value 3 at this point. So if we run this, it should print out 1, 2, 3. Okay, which it does. It's important to understand that this is a linkage. If we make any changes to variables from within the inner functions, it also changes the same variables inside of the outer functions. In this example, we have a function foo, which when called with a input A, calculates B by adding 1 to it, calls the function bar, which decreases that B by 1, and then it calls a print statement with B plus 1. So if we call foo of 1, then A has the value 1, B has the value 2 at this point. When we call bar, this decreases B so that it is set back to be 1. And then we call the print statement of B plus 1, which is going to be our C. So A is going to have the value 1. B is going to have the value 1 as well because it added 1 over here, and then we called B minus minus to subtract. And C is going to have the value 2 because it's B plus 1. It's important to understand that the B over here inside the print statement, the B in the bar statement, and the v on top are all the same variable. It's not creating a snapshot or anything. That is, when this function goes out of scope, it doesn't revert the changes that were made. Those changes persist. So even though the bar function has gone out of scope, those changes that it made to the b variable persist. So this should print out 1, 1, 2 in this example. Okay, and it prints out 1, 1, 2. Let's clear that and move on to the next demo. So in this example, we have the function ask, which takes as its input a string type, and type is allowed to be one of 5 strings: who, what, where, when, or why. And it takes this string and assigns it to a constant, myType, which again declares that this string cannot be changed. It then declares these 5 functions, and each of these functions does something very similar. It accepts a single parameter, and then it prints out, using console.log, a string based off of the myType, again, which we've declared to be one of the 5 words: who, what, where, when, or why, followed by a second word, which can change, in this case for who it's is, for where it's is, for when it's was, etc. And then followed by the inputs. Okay, so it's sort of generating questions. After that, we declare an object, which we assign to the variable questions. And inside this object, we have these 5 functions: who, what, where, when, and why. And then we return one of the functions, depending on what myType was. When we use the square brace operator with objects, it allows us to access properties dynamically. So when we call this function ask on who, it returns back a function that will print out who is, and then the input of this function, which is person. So we assign that function to a variable who question. And then once assigned, we can use it by passing it a person. And it will output who is, in this case, Douglas Crockford. Similarly, if we supply it the input when, then this function will be returned, which we then assign to the variable when question. And when we call this variable, it will say, when was JavaScript invented? Okay, so let's run this first. Okay, so we see who is Douglas Crockford, when was JavaScript invented. So one of the things that you may try to do is try to access myType from outside of this function. Because of lexical scoping, because this variable myType was defined inside of the function ask, you cannot access it from outside of this function. Okay, so if you try to do something like who question.myType, you will not be able to extract out that value, even though we know it exists. Okay, so it's going to be undefined. Now we can inquire about what is who question. Okay, we can inquire about this this variable who question, but this is only going to tell us that this is a function. Okay, so it's going to have this f over here, which tells us that this is just a function. So lexical scoping defines how variable names are resolved in nested functions. Inner functions contain the scope of parent functions. A closure adds to this is the notion that this continues to apply even after the parent function has returned and is no longer in scope. So after we call this function ask, it returns us the inner function. In this case, it returns us who. And then the outer function, what, where, when, why, all of this stuff, it should be gone because we're no longer inside of this ask function. But we're still able, when we call who question, we're still able to not just access this function, we're able to access my type. Okay? And so this linkage is preserved. And this is what a closure is, the ability to still access this variable my type, even after the parent function is supposed to be out of scope. So a common mistake is to think that a closure is a snapshot. A closure is a preservation of the linkage of the variables. It is not a snapshot of its values. You close over variables and not values. If you make changes to these variables, those changes persist. We have a function parent. Inside of it, we declare a lexically scoped variable foo, which is initialized with the value a. Over here, we use a function expression statement to immediately assign a constant, use foo, the function that prints out foo. Because this is a function expression, this is executed after foo is defined and initialized to a, but before foo is changed to be b. But when we use foo, you can see that it's going to output b, which means that this is not a snapshot of the contents of foo. When we call the function use foo, the closure will use the updated value. Okay, and so this prints out b. So closures are used heavily in asynchronous programming, which is our next topic. Typically, we use it to preserve our access to variables after a long delay has occurred and those parent functions are no longer in scope. If we just restrict ourselves to procedural style top-down execution, then we can still use closures. Typically, they're used in scenarios where we want to hide implementation details while also revealing a usable interface. In this example, we have something called the revealing module pattern, also called a factory function sometimes. And this allows us to create class-like structures inside of JavaScript using closures. And the nice thing about it is we never need to use the this keyword. So over here, we have a function dog, which takes in a string input n, which refers to name. And then when we call this function, it creates a variable name, assigns it our given string. It defines a variable age, sets it to be 0, and it defines a variable inventory, which is initially the empty array. We also have a function bark, which prints out the dog's name followed by the string barked. We have a function birthday, which increases age by 1 and then prints out a statement. We have a function pickup, which accepts a input. It uses the array's push method to add the thing that was picked up to the inventory. It prints out a statement, and then it calls a function display inventory. This function display inventory prints out a statement that name has followed by all the items inside of their inventory. The key thing for this pattern is the return statement. The return statement over here returns the functions bark, birthday, and pickup. Okay, so we can think about this as the public methods that every dog has access to. So every dog object that we return back has these three functions. And because of closure closure preserves our access to these inner variables. So because we have birthday and birthday changes age, even though we can't access age directly, we can still keep that value by a birthday. Okay, so over here we create two dogs, Sparky and Fluffy, and we call Sparky.birthday twice and Fluffy.birthday once. Okay, so Sparky is going to have two messages. Happy birthday, Sparky. Your age is now 1. And then again, but the age value will be changed to be 2. Okay, because Sparky in this case, when we call it from the same object, these methods, it's going to refer to the same linkage. It's only when we create a different function call that there are different instances of those properties. So Fluffy's age has nothing to do with Sparky's age. Okay, so Sparky should have the age 2 while Fluffy should have the age 1. And this behaves very similar to class-like behavior that you might see in Java. Over here we have Sparky.pickup. Sparky is going to pick up 2 objects, and Fluffy is also going to pick up 2 objects. And we'll see that their inventory is also separate. Okay. Now, one of the things that we can't do is we cannot call something like fluffy.displayInformation. So even though this function exists, because it was not returned to us inside of our public interface, because we don't have this function inside of here, we cannot access it, and it's going to tell us that this is not a function. Now, this doesn't mean that we can't use it. We can definitely use it. We use it inside the function pickup. Okay, but we can't call it directly from outside of the function. Okay. And then finally, we do a console.log on the object, which should print out these 3 functions. So let's run this. Okay, so let's start from the very top. So, right, so first it's gonna call birthday 3 times. So it's happy birthday Sparky, you are now 1. Happy birthday Sparky, you are now 2. Happy birthday Fluffy, you are now 1. And then Sparky picks up a bone and it adds bone into their inventory. Okay, so picks up a thing, and then we call display inventory, which will display all of their current inventory, which is just bone initially. And then Sparky picks up a chew toy, and Sparky has bone, comma, chew toy in their inventory. And then Fluffy picks up a food bowl, okay, and they add it to their inventory. So Fluffy has food bowl in their inventory, and then they pick up a brush, and so now their inventory is food bowl and brush. And again, notice that it's not related to Sparky's at all. Okay, so each of these variables creates their own closure. Okay, so it's the same variable, the same linkage from within the same, as long as we're using the same methods from inside the same objects. But as soon as we talk about a different object, it's an entirely different set of functions. And then finally over here, if we do console.log Fluffy, we can see that Fluffy is composed of 3 public methods, bark, birthday, and pickup. And this curly f is just defining that these are functions. So now let's try to access fluffy.displayInventory, and we'll see that this fails, this errors out. Okay, so we'll say that fluffy.displayInventory is not a function, so it does not allow us to do this. This next demo generate counter has an internal variable index and a function next, which increases the index by 1 every time it's called. It also prints it out, and it returns a object which has just the function next inside of it. So when called, we can generate multiple counters, okay, and each of these counters will be independent. So if we call counter 1.next 3 times, it will go from 1 to 2 to 3. And then if we call counter 2.next, it will start from 1 to 2. Okay, so let's run this. Okay, so we had 1, 2, 3, and then 1, 2. And so again, this index variable is not directly accessible. This one from outside of here, we cannot access it, but it does exist. Okay, and that is what a closure is. So a closure is when a function is able to access its lexical scope, even when that function is executed in a different scope. So we are still able to access that variable index, even though we are no longer inside of that scope. There's still a bit more that needs to be explained about closures, but we need to discuss asynchronous programming with callbacks first.